Hello, everyone. Welcome to today's webcast on the difference between SOLIDWORKS CAM and CAMWorks. I'm the moderator, Krista Prokos. Before we get started, I want to let you know that you can submit your questions for today's presenter by typing them into the Q&A panel at any time. We'll collect them and address them at the end of the presentation. Now I'd like to introduce our presenter. We're happy to have with us today Jeff Reiser. Jeff is an application engineer at Fisher Unitech and a CAM expert. Jeff, take it away.
Good morning, everyone, and thank you for joining today's webcast. As Krista mentioned, my name is Jeff Reiser, and I am the AE CAM specialist for Fisher Unitech, supporting the SOLIDWORKS CAM and CAMWorks products. Just a quick background on myself before we get started. As I mentioned again, with Fisher, I'm supporting the SOLIDWORKS CAM and CAMWorks products. I have been working in the machining industry as a toolmaker machinist for 17 years, 17 years of CAM experience working with various different CAM products, SOLIDWORKS CAM, CAMWorks, and MasterCam. I'm also a SOLIDWORKS CAM, CAMWorks, and MasterCam certified support technician. And just a quick snapshot of the agenda for today. Welcome introduction, which we've done. And I guess the main thing that we want to show today is what are the differences between the SOLIDWORKS CAM and the CAMWorks products. And then at the end of the presentation, we will wrap that up with a quick summary and then a quick Q&A to answer any questions that you guys submit as we go through the demonstration. All right, so one of the questions that I get asked probably more than any other question is, what capabilities do I have with SOLIDWORKS CAM and CAMWorks? What product is the right fit for me? And this question comes about now that SOLIDWORKS CAM is embedded inside the SOLIDWORKS product with the release of 2018. Some capabilities already exist within the software. You get that with SOLIDWORKS 2018. But do I get what I need to make the parts that we are cutting? And that's what we're going to take a look at as we go through this demonstration. When we talk about the SOLIDWORKS CAM product, the SOLIDWORKS CAM is generally focused on your 2.5 axis machining. So when we think about pocketing, facing, milling, drilling, all those types of operations, those are all included with the SOLIDWORKS CAM. Now, as far as 3-axis surface machining, the question gets asked, can I cut this with SOLIDWORKS CAM? And the question is, or the answer is, sometimes you do have some limited 3-axis surfacing capabilities within SOLIDWORKS CAM. The limitation is that it's a constant Z step down. So there are scenarios where we absolutely can't cut that geometry with SOLIDWORKS CAM, and then there are situations where we can cut it, but the tool motion that we get is not really optimized, and it's not really clean to give us what we're looking for. So if you guys look, you'll see this part on my screen. It's a fairly simple part, but there's a few features that exist on here that aren't really, fall into that prismatic, when we say prismatic features, really definable features. And when I say definable features, I'm talking pockets, contours, all those operations that I previously mentioned. When we look at this, we have an angled face on here, and we can deal with that a number of different ways. When we look at this center cutout, though, you can see that we have these fillets running around here. And when I get asked, hey, can I cut this with SOLIDWORKS CAM? The question is, yeah, or the answer is yes, you probably could cut it with SOLIDWORKS CAM. So I'm going to go in, and just like I would with any product or with any part that we pull into SOLIDWORKS before we start programming, I'm going to go to my setup, and I'm going to select the setup tab, and I'm going to come in and I'm going to define a mill setup. And I'm just going to pick that phase. And all that does is that sets orientation of the part within the machine configuration. Now, once I select that, now that we're working with non-prismatic features, nothing that's identifiable, I'm not going to run through the automatic feature recognition because it's not going to recognize the features that I want to cut. So if I come up here and I click on the setup, and I come down here, and what this does is I can go up and I can select a multi-surface feature. Now when I define a multi-surface feature, we're selecting surfaces that we want to be captured within that operation. So I could come in here and say, you know what, maybe I want to cut this angle face, and then we'll go ahead and green check that. Before I green check though, what I'm going to do is I'm going to look at my pattern options. Now right now we're running the full-blown CAMWorks product. So you're going to see I have a ton of surfacing strategies in here that I can select. Now, with SOLIDWORKS CAM, the only strategy that we're going to see available to us is this area clearance and Z level. So I'm going to go ahead and select that. And then once I generate that, I'm going to tell it to generate an operation plan. Now what it's going to do is it's going to generate an area roughing and a Z clearance operation. So we're going to go ahead and update that, and then we're going to tell it to generate toolpath. And it's going to take a minute to process. The one thing you will notice, when we step outside the 2.5 axis to the 3 axis machining environment, toolpaths do take a little longer to process. There's a lot more data depending on step overs, scallop height, and all that information that we plug in to get the desired surface finish that we're looking for. So with this toolpath process, we could take a look at it, and you can see with the area roughing works good on a part like this, on this tapered face, because basically what an area roughing toolpath is it functions like a pocketing toolpath, where it is positioning in Z and then moving in X, Y. So that works for us. And then when I scroll down here and we take a look at the constant Z level cut that I did for the finishing, you can see how it's restricted to a constant Z step down, meaning it's not going to move it in a simultaneous 3-axis motion. It's going to look at the surface, interpret it, position in Z, and then move in X, Y at that level, move down in Z, move in X, Y, and then continue that process throughout the cut. Now for this particular shape, it works. Everything came out good, everything looks good, so I'm happy with that. Now, I'm going to go back here to my CAMWorks feature tree, and I created another feature here, and I selected these surfaces, these radiuses running around the edge of that pocket. And we green check that, I generate the operation plan, I generate the toolpath, and that kicks me over into my CAMWorks operation tree. And now when we look at this Z-level toolpath that it generated, you're going to see within my parameters here, it's a Z level and it's a constant Z move. And then I have the ability to set my step over, whatever the desired step over is. But the one thing you're going to notice, when we look at the motion, it's still respecting that constant Z. Positioning in Z, then moving in X, Y. Now, you possibly could cut that part and it would come out fine, but when we look at the motion, it's definitely not the desired tool motion that we are looking for. It's not a very fluid cut. I would like to see this, I like my tool motion to be clean, continuous motion whenever I can get it. And what this does is, since this is a constant Z and it's wrapping around these fillets, and since we're not cutting the center, every little section of cut requires a retract. It pulls back out, moves over, comes back down, and then moves to the next Z level. And it's not a very fluid toolpath. It's not a very clean toolpath, and this isn't really the type of tool motion that I'm looking for. Now, everything that we've thrown on this part so far is all included within the SOLIDWORKS CAM product. And now we're going to take a look at same part, different toolpath strategies that are embedded within the CAMWorks product. All right, so same part, I filled this hole in the center. I'm going to go ahead and unhide that. And the reason I do that is, you know, that's one of the benefits of working within the CAD environment, is sometimes I need to manipulate geometry, and SOLIDWORks, being a very powerful CAD tool, makes that easy for me to manipulate that geometry. Maybe my tool's diving down in here and I want to eliminate that. And there's other ways we can do it. We can do it with contains and avoids and things like that embedded within the CAMWorks product, but it's very easy for me to go up to SOLIDWORks, go to my surface, tell it I want to fill, select the boundary, and then it creates that flat surface across there. So now when I create my multi-surface feature, I don't have to worry. I can select that flat and I don't have to worry about whether the tool is going to dive down into there or not. All right, so when we go back to the CAMWorks feature tree, when we take a look at this, I have a couple different features in here. One, I have the radiuses like we had before. And then I have the top face, including that knit surface that I created to keep the tool from diving down in. All right, so when we go over to the CAMWorks operation tree, you're going to see here, I did an area clearance just like we did within the SOLIDWORKS CAM product. And all that is that's just it's just an area roughing. Okay, it's going to function like a pocket toolpath, step down to Z and move an X, Y. The one thing you'll notice here when I hover over this and I go to the contain, I added a containment in here. When we do toolpaths in SOLIDWORKS CAM or CAMWorks, it's always looking at stock and it's always analyzing the entire workpiece. So when I pick this face and I pick this face and I tell it I want to cut it, it still may go outside that boundary depending on where stock is located on the workpiece. So I have the ability to go in here, do a new contain area, and then I just pick the edges around this face and then I expand it however much I need that tool to overlap the edge of the surfaces. All right, and then this is the motion that we're left with. And again, it's a constant Z, machining it over that pocket. All right, now when we come to the fillets that are wrapped around that pocket, again, in SOLIDWORKS CAM, we know we didn't get ideal tool motion. It was constant Z, and that's not really what we want. So what I'm going to do is I'm going to go over here and I'm going to let's take this guy here, and I'm going to generate let's do a multi-axis toolpath on it. Now, just because this is named the multi-axis toolpath, this is a toolpath strategy that comes with the CAMWorks 3-axis milling module. And one of the reasons I like the fact that we get these 5-axis toolpaths with the 3-axis module is there's no toolpath out there that has more control over tool motion than a 5-axis toolpath. The only limitation is we have to post in a 3-axis output. We cannot post in a 5-axis output. So for this particular toolpath, all I have to do is identify a pattern. So I have my multi-surface feature. I'm applying this toolpath. That's the pattern. And for the cut that we're going to do a flow line between curves. So I'm going to pick 2 curves off this model, and I'm going to tell it to morph a toolpath from the top curve to the bottom curve. So once I pick flow line between curves, you're going to see it gives me upper and a lower curve. When I click on upper, you're going to see I've identified the upper curves of that pocket the whole way around. For the lower, you're going to see I've identified all the edges at the bottom of the fillets the whole way around the outside. And then I can come down here and I can modify some of the parameters to get the desired cut that I want. I could do a zigzag, I could do a zig one direction, and then I like to do spiral. Again, fluid, continuous toolpath motion is what I'm constantly looking for. And then we can set our step over at whatever the desired step over might be. We can do 5 thou. And that updates. we're going to go back in here. We're going to hide that guy. Go back to our operations. Now when I hover over the multi-axis toolpath, you can see, since I'm in a full 3-axis simultaneous environment, I can move in all 3 directions all at the same time. So instead of locking in the position, cutting an X and Y, moving down a Z, cutting an X and Y, now I get that continuous fluid tool motion that I was looking for. And now I'm going to go over here and we're going to open this simulate toolpath. And we'll back that up. Shut stock off, turn the workpiece on. We'll slow this down. Everything's got a little bit of a delay due to the webcast. And again, these surface toolpaths, there's a lot of data, there's a lot of information that's has to be processed to run through these. All right, we're going to go ahead and close that and try to reopen it. All right, easy way to deal with that. SOLIDWORKS doesn't want to cooperate. We'll just go ahead and end it, and then we'll fire it back up. All right, so again, that's really one of the main differences. And again, the question's always going to come up is, what can I do with what? And really the best way for us here at Fisher to help you make that decision, you know, if you ever have any questions or if you ever run into any of those concerns, send us the model. We can always put sample toolpaths down to it, show you, say, hey, you might be able to get away with the SOLIDWORKS CAM. It's not going to be ideal. It's not going to give you the smooth tool pathing that you're looking for, but you might be able to do it. Really, the right solution is going to be stepping into the CAMWorks, the Mill Pro module, where you get that full simultaneous 3-axis milling. I'm going to pull in another file here real quick, and we're going to take a look, just another scenario where, you know, when we take a look at this part, you know, when I look at these walls and I look at, you know, it's kind of a large fillet coming down into somewhat of a flat bottom. The problem with this, though, is, you know, could I do this with SOLIDWORKS CAM Pro? Maybe. Up here, I would be fine. I can do a constant Z as I wrap around the outside of this. The issue becomes down here on the bottom. All right, it's not completely flat. There's actually taper. You know, it's minimal, but there's actually taper. So what's going to happen is, depending on the cut direction, it's going to limit the tool motion that I can get. If I want to come down here and maybe try to spiral once I get to the bottom, the problem is, what if this is running up and downhill? Well, then that turns it into a constant Z. And what that's going to do is that's going to force me into getting a lot of retracts. And every time we get a retract, that requires a plunge move back into the cut. So those are, you know, when it comes to surface machining, retracts are really our biggest nightmare, as I like to call them. Sometimes we can deal with them, sometimes we can't. Sometimes we can get rid of them, and sometimes we can't, depending on the surface. But this is an area, this is a part, this type of geometry where I can still go in and I can do the area roughing. rough all that material out of there. And then, since I have the full simultaneous 3-axis options available to me within CAMWorks, I can come in here. And again, I did a multi-axis mill, and I'm using the exact same toolpath that we were using on the other part. Limits me to 3-axis output. The pattern is going to be a flow line between curves. Upper curve is defined as the top of the part. Lower curve is defined at the center. This chain right here, which is actually a hole that gets punched through there. Now, the reason I can select that is because I drilled a hole from this side. All right, so there's not going to be any material there. So that sets the boundary. And what those curves dictate cut direction. I'm going to start top and cut the bottom. But they're also giving me, they're using them to morph a toolpath. And it's going to morph a toolpath between the first curve and the second curve. And now, let's see if it'll simulate this guy. And then we get the desired fluid, consistent tool motion that we're looking for. So I'm going to go ahead and close this. The one thing that I do want to point out, you know, when we're working in SOLIDWORks CAM, we utilize automatic feature recognition, and that automates a lot of the programming process. It can easily extract those prismatic features, those pockets and contours and boundaries and things like that. When we get into the surface machining, it's hard to automate that because those aren't recognizable features. But what we can do is, once I create that multi-surface feature, at that point, now it can become an automated process because I don't need to extract the machinable features. I've already identified them with the multi-surface feature. All right, but now once I get to this point, now I can go generate operation plan and generate toolpath, and CAMWorks utilizes the tech database just like SOLIDWORKS CAM. So any strategies that I have defined for 3-axis machining, any special tooling that I have defined for 3-axis machining, all that stuff can be collected and saved in the tech database just like it is for all your 2.5-axis and automatic feature recognition features and strategies. Now, what I like to do is, once I generate my features, I generate my ops plan, and I generate my toolpaths, and I have this pretty much set the way that I want to have it set up. Things defined, step overs, tooling, everything associated with that is the way that I want it. Now what I can do is I can come back here and I can save that operation plan. And what that does is that will write that back to the tech database. And now the next time that I go through to cut a part like this or something similar to it, I can go ahead and I can load that strategy and still automate some of that when we're working with multi-surface features. All right, so just a quick summary or quick recap of everything that we just went over. CAMWorks is required for full 3-axis simultaneous toolpathing. All right, you have limited surfacing capabilities within SOLIDWORKS CAM, but you're going to be locked to a constant Z. All right, so if you can't get the desired tool motion that you want, CAMWorks Mill Pro provides that full 3-axis simultaneous toolpathing. CAMWorks is also required for all mill turn applications. So with SOLIDWORKS CAM Standard, SOLIDWORKS CAM Pro gives you the ability to do basic turning. Gives you the ability, you know, for OD turning, ID turning, drilling on center, but that's it. You have no milling capabilities, no C, no Y-axis, no dual spindle, no dual turret. All mill turn applications fall within the CAMWorks Turn Pro. So if you're doing some turning and your capabilities expand past just Z and X turning, then CAMWorks Turn Pro is going to be the solution. And then once we get to the point where, 3-axis simultaneous machining, and then we step into 4- and 5-axis simultaneous, then CAMWorks Mill Premium would be the product that you would need to support those capabilities. It's also important to remember that CAMWorks utilizes the automatic feature recognition, knowledge-based machining, and tech database, very similar to the SOLIDWORKS CAM Standard and CAM Pro. Major differences with multi-surface features, a lot of times we have to go in and generate those features. They're not definable features, so automatic feature recognition will not recognize them. And then outside of the milling and the turning, other modules available within the CAMWorks product include wire EDM and nesting as well. So we are a full manufacturing solution. So no matter what type of machines you have, no matter what the manufacturing process is, we have a solution. It's a matter of identifying which capabilities you need and what product fits based off those capabilities. All right, that concludes today's webcast.